So today we're gonna talk about 2020 AMC 10A problem 10. It says 7 cubes whose volumes are 1, 8, 27, 64, 125, 216, and 343 cubic units are stacked vertically to form a tower in which the volumes of the cubes decrease from bottom to top. Okay, so let's just try to visualize this. So it's kind of like when you're playing blocks, you stack the largest cube first. You stack the largest block first. So let me just try to draw this. You stack the largest cube first at the bottom. And then the volume of the cube decreases as you keep stacking the smaller ones on top. Right, like you start stacking the smaller ones. Something like that, and then you just keep stacking the smaller ones until you stacked all 7 cubes. So yeah, and then except for the bottom cube, the bottom face of each cube lies completely on top of the cube below it. That just means that there's no case where I have a smaller cube and I'm trying to stack it, but then actually some parts of this cube, the end part, let's say, dangles off the surface of the big cube. So it's just saying that this won't happen. It's just saying that the cubes are completely on top of one another when they're stacked. So what is the total surface area of the tower, including the bottom in square units? So the bottom is just the bottom of the largest cube. So to this problem, the key to this problem is, first thing you want to figure out the side lengths of the cubes, and it's kind of obvious that these are perfect cube numbers, right? Like, it's kind of obvious. So side lengths are just 1, 2, 3. So S is side length 1, 2, 3, 4, 5, 6, and 7. What can you do with the side lengths? You can figure out the surface areas, right? So yeah, we're already really close to the answer. So one way to do this is you can look at it from different views. So from the top, when you look at it from the top, because essentially, so if you look at it from the top, so you frown down like that, then what you see is actually just like this large square with side length 7 at the really bottom, like that's 7, right? So the side length 7. Then you see a smaller square in there with side length 6, and then with 5, 4, 3, 2, 1, like that. That's just what you see, right? And all the squares you see here, actually, the area of this large square is 49. That's actually part of the surface area, because all these squares here that in this diagram are part of the surface area. And then the bottom view, you just see one lonely square there with a side length of 7, right? Like that. So that's just going to be 49 again. So the top plus bottom is going to be 98. 98 square units. So yeah, 98 square units. And then we also have, the sides, right? Left, right, front, back. Well, those sides all have the same view. So let's just call this view. So we're going to have a radius 1 and then radius 2, radius 3. All these cubes stacked like that. Obviously, different sides have different mirrored images of these views, but the approximate image is like this. You can flip that around the axes or etc. But the approximate image is like that, with 7 cubes, 7 squares. And then the surface area of one of these would be 1 squared plus 2 squared plus 3 squared plus until 7 squared. That's just 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49. That just gives us, so this is 5 plus 9 is 14 plus 16 is 30 plus 25 is 55 plus 36 is 91 plus 49 is 140. Okay, so that's 140, but we have 4 views like this. So we have to do 4 times 140, which is 560. So that's just 560. So 560 plus, so the answer is actually just 560 plus 98, because 98 is the sum of 49 times 2, which is the top and bottom view. And that just gives us 658. And that actually is an answer choice, and we're fairly sure that we're correct because this problem's not that hard, and it's probably not that good trick question. So thanks for watching. Bye.